So we're going to start section 4.3, solving quadratic equations by completing the square. Many quadratic equations cannot be solved by factoring. In addition, graphing the corresponding functions may not result in inexact solutions. Well, that's only true if you're graphing manually. If you're using your graphing calculator to graph, then you will get exact solutions, or at least much better approximation than when you graph manually. You can write a quadratic function expressed in standard form, y equals ax squared plus bx plus c, in vertex form, y equals a bracket x minus p bracket squared plus q, by completing the square. You can also use the process of completing the square to determine exact solutions to quadratic equations. Now, this method to solve by completing the square will work on all quadratics, okay? It's just that if we can factor, we would factor because it's easier, okay? But if you don't find it easier, this way will work all the time, okay? All right, so we're in our first example then. Solve a quadratic equation by completing the square when a equals 1. And you've been asked to solve x squared minus 21 equals negative 10x by completing the square, and then express your answers to the nearest tenth. Okay, so first of all, we're going to discuss that you are not able to factor this one, okay? All right, so what we want to do, we want to make sure that it's in the form of ax squared minus bx plus c equals 0. So that means we're going to have to move the negative 10 over to the left. It becomes positive, so you're going to have x squared plus 10x minus 21 equals 0. Okay, so check to see whether you can factor or not. We want two numbers that multiply to give negative 21 and add to give 10. So our numbers that will multiply to give negative 21 are negative 21 and 1, and 21 and negative 1, and negative 7 and 3, and 7 and negative 3. So do any of these pairs of factors add to give us positive 10? No. Okay, this one's going to give you negative 20, this one's going to give you positive 20, this one will give you negative 4, and this one will give you positive 4. None of these combinations will multiply to give you negative 21 and add to give you 10. Okay, so we can't factor. We are going to solve by completing the square. So on your first step, you want to isolate the constant. Now in our case, the constant is 21. So that means we want to take the 21 and we want to move it to the right-hand side of the equation so that we get x squared plus 10x. I'm going to leave some room between the 10x and the equal sign, and I will put my 21 on the other side. Okay, that's our first step. Step number 2, we want to complete the square. Okay, so we want to take half of 10, which is 5, and square the 5, and add 25. And we're going to add 25 to the right also. All right, I'll just make a note of this and then I'll talk about why. So add 25 to both sides. Okay, so notice that the way we're approaching this is somewhat different, or slightly different, from when we completed the square to put our function into vertex form. So what we did then was we said x squared plus 10x plus 25 minus 25 equals, and then put 21 over on the, leave the 21 on the right. So instead of minusing 21 on the left, we are going to add it to the right. And the rationale behind there is what you do to one side of the equation, you must do to the other side of the equation to make sure that they still are equal, okay, in value. All right, so our third step is to factor the perfect square trinomial. Okay, so our trinomial is here, and we want to factor that. So we know we're going to get a binomial squared. So we square root our x squared, we get x, we keep the first sign, which is a plus, and we square root the last term, so square root of 25 is 5. And so now it's factored, x plus 5 all squared equals, and then combine the 21 and the 25, you get 46. Okay, so maybe I should write that. Factor the perfect square trinomial and combine terms on right side of equation. So fourth step, you want to square root both sides. Okay, so that means we want to square root the x plus 5 squared, and we want to square root the 46. And don't forget, we're going to put plus and minus in front of the 46. Okay, because we haven't specified whether we're looking for a positive square root or a negative square root. Okay, so how do you square root x plus 5 all squared? Well, remember, a square root undoes a square. Okay, so a square root undoes a square. So you are left with x plus 5 when you take the square root of x plus 5 squared equals plus and minus the square root of 46. Okay, and the last step is to solve. Okay, that means to isolate your variable. So we want to bring the positive 5 over to the right. It becomes negative. We usually place it in front of the square root. Okay. All right, so you've been asked to work this out to the nearest tenth. Okay. So the way to do that, one of your roots is negative 5, and you notice you've got plus and minus here, so you want to go negative 5 plus the square root of 46. And you want to go negative 5 minus the square root of 46, right? Because you've got a plus and a minus, you're going to add the negative 5 to the square root, and you're going to minus the negative 5 with the square root, because you have, as you can see, two roots. Okay? All right, so you get your graphing calculator out, or any other calculator for that matter, and you work out what negative 5 plus the square root of 46 is, and you get 1.7823, and so on. And then negative 5 minus the square root of 46 is negative 11.7823. Okay, now we do want to work this out to the nearest tenth. So the roots are 1.8 and negative 11.8 to the nearest tenth. So that concludes our example number 1. In this next example, we're going to continue with solving quadratic equations by completing the square, but this time a is not going to equal 1. So determine the roots of negative 2x squared plus 8x equals negative 3 to the nearest hundredths, which will suggest that you're going to be rounding off a number, and in radical form. Now, when they say radical form, they mean that they want you to give an exact value. That means you won't be rounding anything off. Nothing's going to be approximate. And once you've done that, use your technology to verify your answer. So I'm not going to discuss whether this is going to be factorable or not. We're just going to start straight from the question because it's not factorable. Okay, so we're going to start with negative 2x squared plus 8x equals negative 3. Now, the first step on this question is exactly the same as the first step on our previous example where a is equal to 1. you want to make sure that your constant is isolated, and it is in this case. Okay, so your first step is the same. What is different is our second step. Because we know we are going to want to complete the square at some point, we need to make sure that our x squared term has a coefficient of 1. And the way we're going to do that is we are going to divide both sides by a factor of -2. Okay, so that means we want to divide everything by -2. So -2x squared divided by -2 is x squared. 8 divided by -2 is -8x divided by -2 is -4x. Leave some room, and then equal to -3 over, actually that's going to, yeah, -2, which will actually make it positive. Okay, so +3 over 2. Okay, we're going to complete the square next. So from here on in, we do exactly what we did on our previous question. We're going to complete the square now. So I'm going to go half of 4 is 2, and 2 squared is 4, and I'm going to add 4 to both sides. And now I'm going to factor my trinomial on the left, and I'm going to combine my terms on the right. Okay, so when I factor what's on the left, I'm going to get x minus 2 squared equals, and then 3 over 2 plus 4 is working out to 11 over 2. Now you can do that on your calculator, or you can do that using mental math, so just doing it in your head. All right, and now we are going to square root both sides. Don't forget to plus and minus what's on the right there. And your square root will undo your square, so you're going to have x minus 2 equals plus and minus the square root of 11 over 2. And now we are going to solve for x. So x is equal to, bring your -2 over to the right. It becomes positive, so you're going to have 2 plus and minus 11 over 2. Okay, so you have been asked to work this out to the nearest hundredth and in radical form. Okay, well, when you work through the problem initially, you will get your radical form first. Okay, so the radical form of your answer is here. It is considered exact because you are not actually working out what the square root of 11 over 2 is. Okay? The approximation comes in when you are asked to work it out to the nearest hundredths. Okay? So remember, this plus and minus here indicates that you're going to go 2 plus the square root of 11 over 2. And that you're going to go 2 minus the square root of 11 over 2. Okay, so get your calculators out, and the first one works out to be 4.3452, and the second one works out to be -0.3452. Okay, now we want the nearest tenth. So x equals nearest hundredth, 4.35, and x equals -0.35. Okay, so the roots to the nearest hundreds are 4.35 and -0.35. The radical form is x equal, or sorry, you can just write 2 plus and minus the square root of 11 over 2. Okay, so the last thing you were asked to do was to verify using technology, so we're going to use our graphing calculators. What you want to do then is you want to enter in to y1 your function, okay? So that means you're going to want to take this -3 and you want to move it to the other side of the equation, okay? I'm just going to do that over here. So you're going to take -2 x squared plus 8x, and you're going to move the -3 over to the left, and it becomes +3 and equals 0. Now you want the corresponding function, so you want y equals, so you're going to plug into your calculator y1 equals -2x squared plus 8x plus 3, okay? And then you will, so that's the first step. The second step is you want to find the zeros or the roots, depending on which graphing calculator you have. Okay, and what you should get when you do that to the nearest hundredths is that this root over on the left is -0.35, comma 0. Okay, so the ordered pair -0.35 and 0, and over on the right you should get 4.35 and 0. Okay, so you can see that your answer here and here corresponds to what you get here and here. Okay, so that concludes example 2. So in this next video, we're going to take a look at example 3 and use completing the square to graph a quadratic function. You've been asked to graph y equals 2x squared minus 7x plus 4 by finding the vertex, the x-intercepts by completing the square to the nearest tenth, and the y-intercept, and then label your graph clearly. And I'm going to ask you also to include the axis of symmetry, and the domain and range. Okay, so I'm going to start with the vertex. And I'm going to use my vertex formula, which is x equals -b over 2a. So according to our function, given in the problem, a equals 2 and b equals -7. So I'm going to plug that into the formula, x equals, and I'm going to go negative and then b, so negative and then b, which is -7, over 2 times a, which is 2, and this works out to +7, right? Over 4, which when you work that out on your calculator is equal to 1.75. Okay, so we're not going to round this off just yet because I need to find out what my y-coordinate to my vertex is, so I don't want to do any rounding off just yet. Okay, so I now know that for my vertex, I'll just write that over here, my x-coordinate is 1.75. So I want my y-coordinate, and I'm going to get that by substituting x back into the original function. So I'm going to go 2 times 1.75 squared minus 7 times 1.75 plus 4. And when I work all of that out on my calculator, I get -2.125. Okay, so the y-coordinate then to my vertex is -2.125. Now, I'm going to round these off to the 10th because I couldn't graph as accurately as 100th on this graph, or even 1,000th. So it's just going to make sense to round this off to the nearest tenth. So 1.8 and -2.1. So I'm going to use this to graph my vertex with. The next thing that I want to do is find my x-intercepts. And if you recall, x-intercepts happen when y equals 0. So I'm going to write my function out, y equals 2x squared minus 7x plus 4, and I want to replace y with 0. And that gives me the corresponding equation to my function. And I notice that 0 is on the left. I don't really want to work with it on the left. I'm going to work with it on the right. So I'm just going to rewrite this so that my 0 is on the right. And then the second thing that I notice is that my x squared has a 2 in front of it, and I really want it to have a 1 in front of it. So I'm going to, actually, before I do that, why don't I just isolate my constant first? I'm going to leave some room here. And now I'll divide everything through by 2. Okay, so that's going to give me x squared minus 7x over 2 equals negative 2. And now I'm going to complete the square. So I want to take my 7 over 2 and I want to find half of that. Okay, which means 7 over 2 divided by 2. And remember, when you're dividing fractions, that's the same thing as multiplying the reciprocal. So I want the reciprocal of 2, which is 1 over 2. So this is going to give me 7 over 4. So what I want to do now is square that, right? So I want to take half of 7 over 2, which is 7 over 4, and I want to square 7 over 4. And that's going to give me 49 over 16, and that's what I want to add to both sides. Okay, so plus 49 over 16 and plus 49 over 16. Okay, so I can now take my trinomial and factor that, because that's a perfect square trinomial. So the square root of 49 over 16 is 7 over 4. I'm going to keep the sign as minus. And then over on the right, I want to simplify negative 2 plus 49 over 16, and with your calculator that works out to be 17 over 16. Okay, now I want to work out my x-intercepts to the nearest tenth. Okay, so actually I'm kind of jumping the gun here. Let's square root both sides. Don't forget to go plus or minus. So you have x minus 7 over 4 equals plus and minus the square root of 17 over 16, and isolate for x. So bring the negative 7 over 4 to the right. It becomes 7 over 4 plus and minus the square root of 17 over 16. Okay, so I've got two x-intercepts. Okay, one of them is 7 over 4 plus the square root of 17 over 16, and when I work that out to the nearest tenth, I get about 2.8. And my second x-intercept is 7 over 4 minus the square root of 17 over 16. So when I work that out on my calculator, I get about 0.7 to the nearest tenth. Okay, so now you have your x-intercepts. So you have your x-intercepts, you have your vertex. The third thing I was wanting you to find is the y-intercept. Now the y-intercept happens when x equals 0. So we're going to go back to our function, which is y equals 2x squared minus 7x plus 4, and in place of x I'm going to put 0, and I find that my y-intercept is at 4. So now I will graph. Okay, I have a vertex which is at 1.8 and negative 2.1, so approximately here. And you should label the point 1.8, 2.1. I have an x-intercept, which is at 2.8. So 1 to 2.8 around here. And the other one is at 0.7, which is around here. And I have a y-intercept, which is at 4. And now I can draw my parabola in. Okay, so this is y equals 2, let me just write that a little lower. Y equals 2x squared minus 7x plus 4. Okay, so I've asked you to include your axis of symmetry, so that goes right through here. Okay, where x is equal to 1.8. Remember that that corresponds with your x-coordinate to your vertex. Okay, and I've also asked you to include your domain and range, so I will write that down here. Okay, so domain and range. Okay, well, your domain for your quadratics, as long as they open up or down, will be all real numbers. So I'm going to use interval notation, so from infinity to infinity. And for your range starts at, that should be negative, shouldn't it? Negative 2.1. And it goes up. So all your y values are greater than negative 2.1. So when you write that in interval notation, start with the smallest number. Okay, so we include negative 2.1 and it goes off to infinity. And so square bracket negative 2.1 comma infinity round bracket. Okay, so that concludes our discussion on graphing a quadratic function by using the method of completing the square to solve for your x-intercepts. In our last example for this section, we are going to do an application problem and use completing the square. A defender kicks a soccer ball away from her goal. The path of the kicked soccer ball can be approximated by the quadratic function h of x equals negative 0.06x squared plus 3.168x minus 35.34, where x is the horizontal distance traveled in meters from the goal line and h is the height in meters. Okay, and we're talking about the soccer ball, okay? The horizontal distance of that the soccer ball travels and the height that the soccer ball is. Our first question, you can determine the distance the soccer ball is from the goal line by solving the corresponding equation, negative 0.6x squared plus 3.68x minus 35.34 equals 0. Okay, so this is your corresponding equation to your function. How far is the soccer ball from the goal line when it is kicked? And express your answer to the nearest tenth of a meter. Okay, so let's picture what this might look like. All right, so here is the soccer field, and I'm going to call this the goal line. Okay, somewhere out here is the goalie, so here's the goalie. And we want to know how far is the soccer ball from the goal line when it is kicked. Okay, so we want to know this distance here, okay, which, because it's a horizontal distance, okay, is going to be our x. Okay. Okay, so we take our corresponding equation and we're going to solve for our x-intercepts by completing the square. And I'm first going to start by isolating my constant. Bring that over and I get 35.34. And I want to be sure that my x squared term has a 1 in front of it, so I'm going to divide everything through by negative 0.06. And that will give me x squared minus 52.8x, right? Because positive 3.168x divided by negative 0.06 is negative 52.8x. And that's going to be equal to negative 589. Okay, my next step, I'm going to complete the square. So I want half of 52.8 and then square it. So that will give you 696.96. Okay, and you're going to add that to both sides. We are going to factor our trinomial and combine what is on the right. So when we factor this, we're going to get x minus 26.4 squared. Okay, because the square root of 696.96 is 26.4. And that's equal to 107.96. So now we want to square root both sides. And don't forget to plus and minus what's on the right. And we get x minus 26.4 equals plus and minus the square root of 107.96. Okay, isolate for x. Bring the negative 26.4 to the right. It becomes 26.4. And you have two x-intercepts, okay? One of them will be where x is equal to 26.4 plus the square root of 107.96. And x is equal to 26.4 minus the square root of 107.96. Okay? Now I'm not square rooting my 107.96 just yet because I want my answer to... It's just better to do it that way. You get a much more accurate answer, okay? All right, so when I work out the first one, I get about 36.8, okay, to the nearest tenth. And on the second one, I get about 16.0 to the nearest tenth. Okay, so you have to look at these two numbers and decide, you know, if we go back to our picture, what do you think x is going to represent? Is it going to represent the smaller number or the bigger number? Keeping in mind that this formula helps you to determine how far the soccer ball is from the goal line, okay? And so you're going to have to go with the smaller value for your answer to the first question, okay? Because that's the closer distance. And if I put in our next value, this would be 36.8 meters, okay? Okay, so the 16.0 meters is where the ball is initially kicked, okay? And the 36.8 meters represents where the ball is going to hit the ground, how far that will be away from the goal line, okay? All right, so we can write a sentence for this. The ball is kicked approximately 16.0 meters from the goal line. All right, so B, how far does the soccer ball travel before it hits the ground? Okay, so we're going to use our two values from A to work this out. Okay, so we want to know how far the ball travels before it hits the ground. Okay, so from the moment it's kicked to when it hits the ground. Okay, so it gets kicked here. And it's going to land on the ground around here. Okay, so we know that the ball is kicked 16.0 meters from the goal line, and we know that it's going to hit the ground 36.8 meters from the goal line. So how do I work out the distance in between? Okay, from when it's kicked to when the ball hits the ground, because that's what we want to find out. We want to know how far does the ball travel before it hits the ground. Okay, and so we need to take the difference between those two numbers. Okay, so we want to go 36.8 minus 16.0, and we get 20.8. Okay, so the ball travels 20.8 meters before it hits the ground. Okay, so that ends our discussion on example 4.